RadzionKit here. In this video, we are going to develop a lightweight solution that allows users to propose new features for our web application and vote on them. We'll be using React for the frontend and a simple NodeJS API for the backend, with DynamoDB serving as our database. While the source code for this project is privately hosted, you can access all the reusable components and utilities in the RadzionKit repository, which I'll link in the video description. At Increaser, our community page is the heart of all social interactions within the app. It's still in its early stages, but already includes a panel for profile editing, a leaderboard, the founder's contact info, and a widget for proposing features, which we'll dive into today. We chose a minimalist design for this widget, featuring a simple list with a toggle to switch between proposed ideas and those already implemented. We could have gone with a to-do, in progress, and done board, but our workflow focuses on one feature at a time, making the in progress column unnecessary. This design helps keep users concentrated on voting for new ideas instead of getting sidetracked by what's already done. We utilize a dedicated DynamoDB table to manage proposed features for Increaser. Each feature stored in this table has several key attributes: an ID serving as a unique identifier, the name of the feature, a description, and the created a timestamp which marks when the feature was first proposed. It also includes proposed by, the ID of the user who suggested the feature, and upvoted by, an array of user IDs who have supported it. Each feature is marked with an isApproved boolean to show if it's been approved by the founder, and a status that tells us whether the feature is just an idea already done. You might even add a status like in progress if you're using a board to display features. Our API is streamlined with just 3 endpoints dedicated to managing features. If you are keen on learning how to efficiently build backends within TypeScript monorepos, make sure to check out a corresponding video I'll link in the cards and description, which dives into this topic more deeply. The proposed feature method is crucial to our feature proposal process. It identifies the user's ID from a JWT token included in the request, which is used for user authentication. To stay informed about new proposals, I've set up a Telegram channel where the API sends notifications detailing the proposed features. When a notification arrives, I head over to the DynamoDB Explorer on AWS to check the feature's validity and refine the name and description for easier comprehension by other users. While we could monitor new features with a separate Lambda function that listens to the DynamoDB stream, our current setup with direct notifications from the API is quite effective, especially since this is our only method for proposing features. Before adding a new feature to the DynamoDB table, we set up some default fields. The isApproved field is initially set to false, showing that the feature hasn't been reviewed yet. The status is marked as idea, and the proposed by field captured the user ID of the person proposing the feature. Additionally, the upvoted by fields start off with an array containing the proposer's ID, giving each new feature an initial upvote. We keep all functions related to the features table in a single file. By using helpers from RadzionKit like makeGateItem, updateItem, and totalScan, we streamline the addition of new tables to our application. The vote for feature method allows users to toggle their vote on a feature. If a user has already upvoted a feature, this method will remove their vote. If they haven't, it adds their vote. This ensures that each user can only vote once per feature, maintaining the integrity of the voting process. The features method retrieves all the features from the DynamoDB table, but filters out those that are not approved, allowing only the proposer to view their unapproved ideas. This method also calculates the number of upvotes each feature has received and checks if the current user has voted for the feature. Rather than returning the full list of user IDs who have upvoted, it provides a streamlined output to enhance clarity and usability. Now that we've set up the server-side logic, let's move on to the front-end implementation. The features widget is located on the right side of the community page, utilizing the product features board component. This content is arranged within a panel component which has a minimum width of 320 pixels and takes up the remaining space in its parent container. The header of the panel displays the title product features and includes the product features view selector component, allowing users to toggle between the idea and done views. The render product features view component is smartly used to only show a prompt for proposing new features when the idea view is selected. The product feature list component is then used to display the list of features. Switching between different views is a common requirement in many applications. To address this, we use the getViewSetup utility from RadzionKit. This utility accepts a default view and a setup name, providing a provider, hook, and renderer that facilitates convenient conditional rendering based on the current view. For the view selector itself, we implement the tab navigation component from RadzionKit, which takes an array of views, a function to identify the view name, the active view, and a callback to update the view. The proposed feature prompt component employs a call to action within the panel prompt component. When triggered, it unveils the proposed feature form component. We also make use of the opener component from RadzionKit, which serves as a wrapper around the use state for conditional rendering. I personally prefer using the opener for its streamlined syntax, so you may find a simple use state hook suits your needs just as well. In the proposed feature form component, users can input a name and description for their future idea. We keep the validation simple, just ensuring that these fields are not left empty, since I manually approve and edit each feature afterwards. The form's onSubmit function checks if the submit button is disabled, and if it's active, it calls the mutate function from the use proposed feature mutation hook with the new feature details. After the mutation is initiated, the onFinish callback is triggered to inform the parent component that the submission is complete, which then prompts the proposed feature prompt to display the panel prompt again. To display the list of features, we start by retrieving the query result from the API using the useAPI query hook, which requires the name of the method and the necessary input parameters. The query-dependent component from RadzionKit is then used to effectively manage the query state. During the loading phase, a spinner is displayed. If there is an error message appears, and in the success state, we render the list of features. These features are sorted into two arrays: my unapproved features, which include features proposed by the current user but not yet approved, and other features, which encompasses all other features sorted by the number of uploads in descending order. Each feature is then rendered using the product feature item component. To minimize probe drilling, the product feature item component receives the current feature through the current product feature provider component. Given the frequent need to pass a single value through a component tree, I developed the getValueProvider setup utility function in RadzionKit. This versatile function accepts the name of the entity and provides both a provider and a hook for that entity, simplifying the process of passing contextual data to nested components. The product feature item component displays the feature's name, a cropped description, and includes a voting button. To accommodate two actions within a single card, the component follows a specific layout pattern. Users can click on the card to view the feature details in a modal, while the vote button lets them cast their vote separately. Because HTML restricts nesting buttons, we use a relatively positioned container for the card with the vote button absolutely positioned within it. This layout challenge is so common that RadzionKit offers a solution called Action Inside Interactive Element, which greatly simplifies the implementation of multiple interactive elements within a single component. We use the opener component again to manage the modal state for displaying feature details. To prevent the title from overlapping with the absolutely positioned vote button, we insert a spacer component with dimensions matching the vote button as specified by action inside interactive element. To maintain a clean appearance on the card, we crop the description using the max text line CSS utility from RadzionKit. Additionally, if a feature is still pending approval, we display a shy info block component to inform the user that their feature is awaiting approval. The vote for feature component features an upvote button that provides a simple and intuitive voting interface. When clicked, it activates the mutate function from the useVote for feature mutation hook, passing the feature ID as an input parameter. The upvote button includes a chevron icon and shows the number of upvotes. It changes color dynamically based on the value prop, visually indicating whether the user has already voted for the feature. In the product feature details component, we display the feature's creation date, the user who proposed the feature next to the voting button, and the full feature description. To access the proposer profile details, we utilize the user profile query dependent component. This component checks if the user has a public profile, displaying their name and country, or label them as anonymous if they chose to keep their profile private. The user profile query dependent is a refinement of the query dependent component, offering a more streamlined way to access user profile information. That's all. If you liked this video, please like and subscribe.